Okay, we are about to start. If you have any question, please feel free to write in the chat. We will read them and we will try to answer. I hope everyone from home can hear me well. If there are any problems, please, of course, write it in the chat. We have my colleague Francesca that he's here to answer your requests and your problems. And so I think we can start recording the event. Okay, perfect. The event now is recording. And I just want to say again, thank you for being here, both for the people online and for the people here in person. We are very pleased you accepted our invitation to join this first event of NaturSea-PV project. My name is Sara Tana. I'm the dissemination manager of NaturSea-PV project. My company is called Warrantab. So in Warrantab, we are a consulting company that we help companies, research centers to write and submit proposal, but also to participate in project management and dissemination. This is why we have organized this event. So I just want to start this event with a short presentation of our project, NaturSea-PV. So for doing this, I asked to the project coordinator of the NaturSea-PV project to come on the stage and to just give a short overview of what the project is about and the main objective, because I just want to say that the main aim of this event is to collect feedbacks from you, both here in the room and online. So please feel free to write in the chat or also say something that you want to add, something, your feedbacks regarding the project and regarding the technology we are going to present you. So please, Juan Gaetero Redondo from Tecnalia, the stage is yours. I give you this one to change the slides, and the stage is yours.
So thank you very much for, can you hear properly, first of all? So first of all, thank you very much for your kind introduction, and thank you very much to all the people that is here in person and for all those that were online. It's a pleasure to be here presenting this or taking part in this first public event of NaturSea-PV project. Of course, it will be the last. And well, let's start with the motivation of the project. Well, I heard that we all know that Europe ambitions to become the first climate neutral continent by 2050. And in addition to that, they want businesses and citizens in general to benefit from that green transition. Of course, green energies in general will play a key role in this transition. And the problem is that those green energies occupy very large areas of land generally. Then they compete with other more traditional uses of that land. So a solution is needed, and that solution could be placing them in the water. So in the case of wind energy, for example, the transition already began many years ago and is quite well developed in shallow waters. In the case of photovoltaics, the transition has begun a few years ago, and they are already quite developed, but only in the still waters. So the question is, could they be these photovoltaic facilities based on the sea? Of course, in this project, we think they can, they should. And the objective here is making those facilities more reliable, of course, cheaper somehow, and in the end, making the production of that electricity cheaper, so that it becomes economically viable. So in this project, as we want to contribute to that, and for that we have an original approach, of course. We want to develop a nature-inspired solution that is follows this lily concept you can see here in the image, that is composed of some horizontal beams and some vertical floaters. And this whole structure that will allocate the PV panels has to be somehow flexible to deform with the movement of the waves, but of course, solid enough to withstand the hard conditions of the sea. The objective in this project is withstanding the strong winds, the strong currents, and waves of up to 14 meters. It's quite a lot, in my opinion. And what are we going to with that? Well, for that substructure, we rely on a material that is ultra high performance concrete because it has a very good performance in terms of elasticity compared to regular concrete, in terms of durability, of course, and also in terms of strength. Yeah. But in this project, we want to do it in also it's a great material. We want to try to do it more ecologic, reducing its carbon footprint, and if possible, also cheaper, of course. Apart from that, we are going to work on the development of bio-based coatings to protect the materials, not just the concrete, but also the materials that will be in the whole PV facility from fouling and from corrosion. Not all the parts can be made of concrete, of course. And well, our colleague Esteban from RDC will give you more details about this in a few minutes. Apart of that, we want to develop new predictive computational methods to predict the durability and the performance of the material and the whole structure on those harsh conditions. We will develop a mesoscale model that allows to predict how chloride integration will take place in this kind of materials. In the case of ultra high performance concrete, and particularly ultra high performance concrete, is not known. So our colleague even from Darmstadt will give more details. And then, of course, it's very important testing all these solutions on realistic conditions. We cannot make the whole structure for real and put it on the sea. So we will test it, as you can see in the facility of Marine, that nice wave tank. The part of the materials will be tested in the sea, in the HAS lab. This yellow structure in the middle that is placed in the close in the Basque Country, in the coast. It's a facility of Tecnalia. And of course, complete elements, the beams and the floaters, will be tested also in realistic condition in the sea. The beams in Galicia and the floaters in the Basque Country. But apart from those technical developments, it's also very important to assess the impact that all these solutions can have in the environment, in the socioeconomic activities that take place in the sea and so on. Because, of course, we all want green and cheap electricity. But probably no one of us wants to have one of those facilities just in front of your favorite beach or something like that, or your fishing area. So how can we handle with that? Well, our colleagues from the University of Cork will work with different groups. This event, this co-creation event, pursues also dealing with those kind of issues. And that's why we try to involve that many people to participate in this event so that they can provide their opinion. Maybe these solutions are only for very specific locations. Maybe we should change our design somehow to facilitate, I don't know, whatever. So all that has to be assessed. Also, of course, the regulatory constraints. Do current regulations encourage or facilitate the development of this kind of structures, or do they hinder it? Our colleagues from Cork will study that and will give you more information in a few minutes. And well, for doing all that, we have our NaturSea project. This project just began a few months ago in November, and it will last for 4 years. So we have plenty of work ahead, but we have also some time. I have to say that we have a great team composed by 11 institutions from 7 different countries. We have one additional institution from Portugal that will join us in a few weeks. We are signing now the papers and so on. So I think that the project is very nice. We are going to get very interesting results and hopefully change a little bit Europe and the future of green energies in general. So I hope you all enjoy this event. This is everything from my side. And now I think time for
Thanks, John. Of course, we have time for questions at the end of the event, but feel free to ask whatever you want in the chat, putting your hands up in the Teams call, or putting your hands up here. Don't be shy. Okay. I think there are no questions for the moment. Yeah, no question. Very well. I think that John presented very well and everything was clear, so no question for the moment. And it's the turn of the next presentation. So now we will talk about floating offshore structure. I asked to William Otto from Marin, one of our project partners, to be here on the stage. Maybe, sorry, I just share the presentation in another way because it's not very good seeing the presentation like that. Okay. So if you want, William, the stage is yours. Can you stay here? Perfect. I give you the microphone.
Thank you. My name is William Otto. I'm working at Marin. And I will try to explain in like 10 or 15 minutes the structure we are thinking about in this project. As you know, it will be made of concrete and it is inspired by a water lily. Actually, quite a nice movie has been made to explain this structure. The movie is made by our partners from Warrant Hub. So you might know these things. In reality, they can become like 2 meters in diameter and they can carry a baby. You all have seen those lovely pictures, I guess. If you turn that upside down, then you see that it's actually composed out of girders. And these girders, they span a sheet. And well, what do you want to have if you design a floating solar plant? Basically, you want to span a lot of square meters or hectares, basically, with the least amount of materials. I think that is one of the main design drivers, creating hectares with the least amount of materials. And we were looking at how does NaturSea do this. And these water lilies actually they do that. Darwin made them such that they get as much sun as they can with their sheet using the least amount of girders possibly. So that is basically the starting point of our concept. And then what we will be doing is first designing that with our numerical tools, and then later on test that model scale in one of our model scale laboratories, and then also test part of it outside at sea. So the design, the concept is completely new, and therefore it is at really low TRL at the moment. And in the next 3 years, we try to bring that a bit further on the TRL ladder. So here, this picture is just a starting point. So this is not the end design, but this is what we take it from here and then analyze it and develop it further. So the Lily concept, it consists of radial and tangential girders. And we anticipate to make these girders out of lightweight concrete, eco-friendly concrete, flexible concrete, ultra high performance concrete. So this, just like the water lily flexes with the water surface, this structure is also meant to flex with the waves. Flexible concrete elements. So these girders, they provide support to a lightweight sheet which spans the construction like an umbrella. And this sheet is still to be designed. So it's you have to see this as a low TRL starting point, which we will bring further. But yeah, like it's a lightweight deck on top of a flexible concrete girder structure. The call text mentions that we should be able to withstand 14 meters waves, and there the biggest difference with the nature of the water lily comes into play. Water lilies, they you only see them in sheltered areas like in the Amazon and in lakes, and there you don't have really big waves. So we wanted to improve the beauty of the water lily towards the harshness of the sea, basically. So therefore, we had to adapt it, and the adaptment is that the whole thing is raised. So instead of that, the sheet is floating on the surface. It is carried by these floating columns, these floaters here in yellow. This concept needs to be completely designed and optimized, and that is what we will do in this project. And what we will do is we define KPIs, so key performance indicators. One of them, obviously, LCOE, so levelized cost of energy, but also like another KPI. Personally, I think is energy payback time. So we need to have some energy to construct the thing, and it will also produce some energy. And this time to pay back the energy that the construction took, preferably only a fraction of the lifetime of the construction, as you can imagine. Many KPIs, defining them is also part of the project. And what we will do is this concept, which is of a further to be defined number of girders carried by a to be defined number of floaters. Well, we are going to map that. So how are the KPIs influenced by choosing the amount of floaters, the amount of girders, and making sure that everything stays in one piece, of course. So the approach is that we will create a large set of design variations, use low fidelity tools to estimate how they score at different KPIs, and then from there convert towards a solution, and then in the way, of course, switch to higher fidelity tools, making better assessments. And in the end, we end up with the most high fidelity tool we have, which is the model test based in so to make this a bit more concrete, not material concrete, but This is like a systematic design variation. This is like a top view. You can here we vary the amount of floaters and with it the amount of girders. You can make it having one outer circle or two or three. So here I call it rings, and slices can have many varieties. And these are all design choices. And what we want to assess is the impact of these design choices on the durability, on stress levels, on the LCOE, and on the other KPIs that we have defined. This one will be our starting point of the design, being 13 floaters, having a diameter of 4 meters and a height of 6 meters, of which about half of it will be below the water and the other half being above the water. 28 beams standing on top of these columns, beams with a certain cross section and a certain length. That's the starting point. From there we will vary further and see how we can make this flexible, durable, and scoring well on our KPIs. We are going to vary a lot of parameters and see the effect of it. It's quite easy to end up with a large set of designs, and we are going to assess them all with using low fidelity tools and then look for design trends and then switching on to high fidelity. This is how the thing will behave in waves, like the proposal text mentions that we should assess 14 meters waves, but we already have indicated that it's probably not the highest wave which will be most difficult, but it will be the steepest ones, because wave steepness and wave length is more critical for the structure than purely the height. So we will assess each design with a number of different waves, and like for the short waves, which are much smaller than the length of the structure, it will move basically like the one on the top right, or waves which are in about the order of length of the structure itself. We anticipate that these girders will have high stresses. That's what we need to examine, that they don't break, of course. And then the really long waves, this will be the highest. So the bottom part will be the 14-meter wave of the vortex. We anticipate that one will not be the biggest challenge for the construction, as it will just move with it. So it moves just up and down and follows the slope of the wave. So I would say the top right is the key focus of our analysis. So we are going to assess all these designs with all these waves, and we will be looking at air gap. So it's basically looking if the deck stays dry. That's the intention. And looking at bending stress in the girders, whether the girders are capable of dealing with the stresses. And then the question is, of course, to not only be able to deal with the stress one time, but to deal with the stress millions of times. Because we anticipate that in the lifetime there will be like 100 million stress cycles. So basically 100 million waves. So for this we will assess different waves with different lengths, like having the same wavelength as the structural length, a bit short, a bit longer, and like for each wave we will assess the highest possible at that length, which is about 1/7 of the length. You would make the wave higher than that, it will break, and then wave slower again. So we will do this analysis using simulations. It will be dynamic simulations. We will define LCOE function for all these designs, so calculating the cost of it, and also estimating the cost of all the other KPIs for all the designs we have. So there are a lot of calculations. So the calculations They need to be simplified a bit because otherwise it's infeasible to assess many designs, but it's really meant as a screening. And at the point when we really make decisions, then it's time to look in it a bit more detailed. Yeah, this is the random numbers, but this is like how I anticipate that the end result of our work will look like. So like we intend to make something like a graph in which each dot represents a certain design. So and a design is a selection of the girder length, amount of floaters, amount of girders, and so forth. And then really look for each design. Okay, what is the LCOE plotted here on the vertical axis? What will be the maximum girder stress for doing to the waves? And then really look well what is being best design as compromise needs to be sought in different KPIs. That is in really short the concept of NaturSea-PV.
Many thanks, William. Someone has any question? We have three questions from the audience here in person. So I start here. Hi, good morning.
Joep van der Zande, also from Maden, so a direct colleague of William. What kind of material are you planning to use for the girders? And I was also curious where the elasticity will be introduced. So are you also thinking of introducing hinges, for instance, to further increase the elasticity of the design?
Thank you, Mr. van der Zande, for this question. Like the connections, whether they are clamped or pinned or laid up, that is also a design variation that we will look into. At the moment, we look at clamped connections, but pinned connections will also be a thing we consider. Regarding the material of the girder, it will be like the concrete. So the floaters as well as the girders will be made of concrete. And maybe Esteban can tell a bit more about that.
After, okay. So we leave space for a question and then we will talk about the material. Okay. Do you want to finish? Yeah.
Oh, yeah. Esteban has a complete presentation about this maybe in the next agenda point. Yeah.
So another question here. Many thanks.
I'm wondering a little bit about the resonance condition when the waves are equal to the structure. So in this question, when you have resonance, what you intend to define what is the material that will survive to that, or a change of the design according to the wavelength could be also another option. Understand?
Yes, it's a really good question, as the stress in the girders can be very high if resonance occurs. So basically, the aim is to find designs which do not resonate. Basically, to tune the natural frequencies of the construction such that they do not coincide with the frequencies of the waves. And by spanning a large set of design variations, we anticipate that those non-resonating designs will be in our design set. But if we, in the course of the next year, find out that it's impossible to avoid resonance, then we need to think about applying some damping somewhere. But that's really Plan B. Plan A is to have the tuning of the natural frequencies outside the wave frequent regime. Thank you. Good question.
We have another question here. Morning.
I had Emilia from Galp. So I have a question on a personal suggestion on the KPIs. That I see the list was open. So I think the CO2 content of the CO2 life cycle analysis of the core structure is relevant to take into account. And the other thing was related to the mooring part, and whether it's also focused within the project. Maybe there's presentation later on, but just to have your views on the mooring and on the slack, it's required. Also thinking, visualizing that maybe you have several lilies operating in parallel in the same site. They need the slack for the wave to absorb the wave height, but they cannot chop together. It's very illegal.
Thanks.
Yeah, regarding your point on the KPI, that's the CO2 life cycle of the whole thing should be taken into account. I think that is a really valid point. So that's what we should do. Indeed, the list of KPIs is open till the end of April. So we have plenty of time to take everything into account. Regarding the mooring, that is indeed also part of the project. We know that mooring systems will be very water depth specific. So we will end up with different design for it for different water depth regimes. My expectation is that it's that we will need to have quite a distance between two lilies, because if you don't want them to classically put them close to each other, you need to have the stiff mooring, which is probably infeasible in terms of loads. We will do calculations to confirm or not confirm that. But yeah, that is probably we would need quite a distance apart in order to have sufficient offset margin for the limits. Yeah, that is that's like next step. First step is making the concept work for the lily, and then
Following it, but taking into account the length of the power cables, the marine power cables, because when it is analysis, you might want to what dimensions of the rather than the other one.
Yeah, the question for the people at home was about the power cables, and dynamic power cables will be a major challenge for all these floating solar plants and also floating wind farms, and that is not the scope of this project. No, I agree that dynamic power cables to the sea, that will for fatigue especially be a major challenge, but not for this project.
Perfect. Sorry, but we have also a question from home. I see one hands up from Yannick Perko. Hi, Yannick. Good morning.
Hi. Good morning,
Hi.
everybody in Amsterdam. Thanks, William, for this presentation. I have one question. I would come back to these KPIs because, well, you will use KPIs to compare between different designs, and you will use them to optimize the system at the end. You said that the list is still open, but okay, one is the list, and the other thing is how do you weight them? Who will decide the weights of the KPIs for the optimization, and will these KPIs or the weights be different depending on where you will place them, depending on, let's say, type of waves or whatever things? Thanks.
Thank you for your question. I think indeed the weighing of the KPIs is really important, and we will have project discussion on that also this afternoon. The answer is that the weighing is not decided yet. Personally, I think that I hope that the weighing will not be too much on the LCOE, but more on like energy payback time, more on carbon balance. Yeah, the weighting of the KPIs is an important topic, which the project still needs to have a discussion on. Yes.
Vale. No, pues no me podía conectar ahora, llevo un buen rato. Gracias.
Good morning, Julia. Can you switch off your microphone?
Buongiorno.
Perfect. John, we have one message from you in the chat. Is it possible? Maybe it's another John. Oh, lots of no, maybe it's another John.
Yeah, it can be from Ireland.
Ah, okay. Oh, okay. Lots of questions in the chat. So we start from the first one. Juan says, hi, how are you testing the fatigue resistance of the material for these connections? Any requirement to meet on fatigue?
At Marin, we will define what the fatigue loading is. And the question whether the material can cope with that fatigue loading will be dealt with by work package
2 and 4.
2 and 4. Yeah. So it is a good question, and the answer will follow in the next presentation.
Perfect. So another question, great presentation. How will you be calculating the cost of the mooring system for each design size? Presumably the wave and wind loads will be different for different unit array size. How will this be estimated? Also, what is the general mooring system concept?
We anticipate to, just like the water lily. The water lily has the mooring in the center. It's basically one stem. Probably we won't be able to engineer it as one stem, so we anticipate that it will be multiple mooring lines. But the mooring system concept will be that these lines concentrate in the center to stay true to the water lily concept. Indeed, for each design, we basically need to engineer a mooring and estimate the cost of that. How will this be estimated? Yeah, we would need to make some simplifications there before, because we want to analyze a lot of different constructions and then detail it further in the course of the project.
Perfect. I've seen lots of questions related to concrete. So maybe I will leave the floor to Esteban Camacho that will give his presentation, and then we can read the question related to UHPC material and concrete. And I think that Esteban it is the more how can I say perfect? Is the perfect expert? Yeah. Please, Esteban from RDC Concretes.
Hello, everyone. It's the first time I answer questions before the presentation.
No, you can give the presentation and then answer a question, because maybe the question that the person made from home is already in your presentation. I don't know. So
okay, no, perfect.
We'll hear your presentation and then we'll see if the presentation matches with the answer.
Okay, thank you very much. In any case, the presentation is more conceptual because I am not in charge of any work package. So the name is UHPC, a material to unlock the potential of the blue economy. Well, as was already mentioned here, water means 71% of the planet's of the Earth's surface, of which 97% is salty water, so salty with chlorides and so on. And only or less than 3% of the economy develops on the water. This is something which sounds shocking. And the European Commission already proposed in 2015 a plan called the Blue Economy Program to try to increase this percentage of the economy that represents the sea, no? the economy that develops on the water or maybe on the ocean. And it is, well, maybe it's working, but we really didn't notice a significant increase. And one of the main reasons, at least from my point of view, is the harsh environment of the ocean. Okay, as it was already told here, the ocean water has chlorides, dynamic loads, fatigues with more than million cycles per year, abrasion of the water and the elements that are in the water against the structures, extreme temperatures. Also, in many oceans, we have less than 0 degrees, and also a costly and hard maintenance. So, in general, it's interesting. It's a key for the development of the blue economy to have lighter materials and more durable materials. Lighter because it costs a lot of money to bring the structures to 10 miles or 20 or 50 miles from the coast. This means money. And more durable also because we don't want to send people to do these expensive and these risky activities of maintaining these structures. So in general, have a lighter and durable structure and material. It's a key, but also to have a cost affordable material, because obviously the more expensive is the material and the more technological, the more difficult will be the development of this economy. Well, up to now, one of the most promising materials we have experienced is ultra high performance concrete. This is a type of concrete, as you can see in the name, which has a higher performance, not only higher strength, but higher performance in a wide sense. Okay, in the case of the sea, the most relevant is not particularly that it has more compressive strength or flexural strength, but is mainly the durability. The durability in uncracked state, which comes basically from the low water binder ratio and the high capacity of the binders of the components, but also the durability in cracked state, because the fiber content is so high that when the material is cracking, you don't experience a large crack where the chlorides and the water will penetrate and the oxygen, but many micro cracks that are really more durable than a single macro crack. Well, UHPC is a combination. The laser doesn't work, but whatever. It's a combination of 3 technologies of concrete that develops in the last years, in the last decades, which are the laser. Don't worry. Okay. Which are self-compacting concrete, fiber reinforced concrete, and high strength concrete. The combination of all these is a UHPC, a technology that is really very wide depending on where you focus. It was mentioned before that UHPC is flexible. It is and it isn't. The material itself is more stiff than normal concrete because the young modulus is higher. But as the performance is higher, we can design structures with less material. So the result is that the structure can be more flexible because the structure is more slender. You can see an example of one of the beams that we produce in the factory. This beam has a slenderness of 150, and it is, as you say, the structure itself is very flexible. When it bends, if we bend it a lot, the deformation is significant. And as I already mentioned, instead of one macro crack that is already a problem for the future, we have multiple micro cracks of 20 microns, 30 microns that really close when the beam comes to the normal position. No? So it's flexible and it's durable. This is a conclusion. We have made several structures already with UHPC, but for example, this is a UHPC footbridge that makes sense because it's only 200 meters from the sea, so the environment is already aggressive. Where does UHPC make sense? This is a big question because many people didn't know, we neither in the beginning, where to use UHPC efficiently because it's more expensive. Okay, so the answer is Normally, UHPC makes sense there where durability is significantly required, there where being durable provides a competitive advantage. This is the first, the top part. There where lightness provides a competitive advantage. So if I have a lighter solution, I save money. Or there where aesthetics or slenderness provide a competitive advantage. And it's difficult that a solution that is not in this pyramid, it makes sense with UHPC. So maybe your solution that is not only the durability, but the durability and the lightness, or maybe the aesthetic and the lightness, but it's always a combination of this, the solution that makes sense with UHPC. And normally all solutions that are in the sea are between durability and lightness. Why? Because as I already said, a lighter structure is easier to make it float. It's more economic to make it float, but it's also more durable. All the most of these structures we have already made and installed in different situations. As you can see here, these are examples of successful structures made with UHPC, our design, and we also produce them. The first one and the last one are also patented solutions. So if you want, we can start from this one. These are floating farms made of UHPC. We have already more than 30,000 square meters of these, and the maximum wave height of these structures is approximately 4 meters. Okay. Here, the key is that we are replacing the typical solutions that are made of wood. Wood is flexible, but the maintenance costs are very high. Okay, so our solution is a little bit more expensive from the first day, but very soon, after 5 or 6 years, it's already more economic due to the savings. Okay, this structure is exactly as flexible as a wooden structure. If we go to the left structure, in this case, this is a perimetral pontoon made of UHPC to protect a floating solar system, which is composed of plastic floaters. In this case, the solution is competitive simply because the alternative with ordinary concrete is 4 times heavier. So 4 times more transportation, 4 times more cranes, and so on. So this was the most economic solution. And in the central one, you can see some kind of nutshell, a 6 centimeters nut, a shell that is a pre-slab that later is filled with ordinary concrete. So this is an economic way to guarantee 100 years of durability in a port only with 6 centimeters of material. And later we put there inside ordinary concrete that doesn't have these durability requirements because we already guarantee everything with a light structure that is really easy to commission. So here in the central one, the commissioning costs, the installing costs are much lower than other alternatives. And we have installed this because these are the most economic solutions from the first day or after 5 or 6 years. Despite of this technology and developments, there are still many challenges and limitations. I generally say that UHPC is like ginger because we all know that it's very good, but we don't know how to use it or where to use it. As I was telling, I think that the main barrier is that engineers really do not know in which field really to use it. And also some clients or many clients, they don't know that they are potential clients. They need UHPC, but they don't know it. So as they don't know it, they don't call us. So this is the problem. We need to develop, we need to shape the market with projects as NaturSea, to show to the people that UHPC can really be used in some sectors where no one imagined that. One of the main keys is that the material is expensive. Okay, expensive is a relative word. It's expensive if you make the same designs, but if you optimize the element to understand that you can use less material and transport less material, then costs are relative. Okay, regulatory frame is still a significant barrier because we don't have so many norms yet in the countries, and the lack of success case stories. But it's true that every day we have more examples of successful uses of UHPC. Well, we are facing many of these barriers and limitations with the NaturSea project. I will not speak about the Lily because they already explained a lot. But the thing is that in this project, we will design a large substructure of UHPC, and at the same time to optimize the costs of UHPC and their sustainability. And these two tasks are really related because the design of the structure is fully directly related with the capacity and properties of the material. We still don't know if the most sustainable solution is a UHPC with a high carbon footprint, but using a low amount, or a combination of a weaker UHPC using more material. This is the main analysis in work package 1 and work package 2. In work package 4 and 5, we will prove that these structures in TRL 4 and 5 are really working after 12 or 18 months. We will prove if these structures are really useful to our goals. And in work package 6, we will do something that I think we are missing out nowadays, is to broaden the number of stakeholders, the people that really know what is being done with UHPC. We need to shape this market for future sales. So as I was telling, there are UHPC tasks in this project specifically focused in UHPC, which are to develop an eco-UHPC using eco-cements, recycled fibers, recycled aggregates possibly, and also focusing in the concept of circularity. We will explore also in our factory new curing system to boost these properties of the eco-UHPC. We will evaluate, as I already told, the performance of eco-UHPC in the TRL 5 or 6 with elements as these rings and floaters that Otto mentioned. And we will develop bio-based and defoliants to protect these structures from the fouling. And this is mainly the presentation I wanted to do. If you have questions.
So I just want to check the question that was done before, because I think that you can answer. It's a question related to, okay, there are 2 questions. So the first one by Mr. Alev Iksa. Oh, okay, another one. Okay, sorry, one moment. Lots of questions. We are very happy about it. Okay, so the first one, it's what is the unit weight of the concrete? As it is an UHPC, what is the strength target for your concrete? And what sort of reinforcement is used in the concrete?
Well, all these questions are relative. UHPCs can have binder contents between 500 and 1,000 kilos per cubic meter. Please don't move because I am reading the questions. So it's relative. Obviously, it's higher than in a traditional concrete, that you are using lower volumes of material and they last for long. So it's a relative question. The strength of the target of our concrete. In our case, I already mentioned, I don't know how much we can afford to decrease the performance of the concrete, because this depends on the equilibrium with the sustainability. Nowadays, the UHPC we produce has 160, 165 megapascals on average after 28 days and without steam curing. The reinforcement used, normally all these structures are pre-stressed or with post-tension, but normally pre-stressed. The next question is, I think, is the same. Yes, a cubic meter of UHPC normally has a CO2 between 10 and 30% higher than ordinary concrete. But we are sometimes reducing the weight of the structure up to 70%. So we already have, for example, for the floating rafts, we have a publication that shows that the floating farms with UHPC are more sustainable from day one than wooden structures. What is expected the service life of UHPC under marine environment? Big question, because the UHPC itself has a very long lifespan, but you are connecting elements of UHPC and you are mooring them. So I trust the beam itself, but we also need to consider that the connections can fail and that the mooring can fail. So in general, UHPC itself has durability much longer than 100 years. Is the UHPC precast or mixed on site? All these elements are thought to be precasted in our factory. So maximum length of 40 meters maximum, and we can connect them on site. Is UHPC or UHP-VRC? Normally, both concepts are similar. UHPC is an abbreviation of UHP-VRC, but it is UHP-VRC, so it has fibers.
Thanks. There's a question also here in the audience.
It has a lot of fibers, so then what about the rheology?
It's a self-compacting concrete. It's designed to flow, and despite of having up to 200 kilos of fibers per cubic meter, you can mix it and you don't need to vibrate it. In this case, there are also knots of compacting UHPC. You don't believe me? According on your face.
That's a question.
We will visit you.
No. The design of the granulometric curve and the selection of the fibers is done specifically for this, to make it flow.
Other questions? Yeah, one question here.
Just ask if the circularity of the materials will be as part of your project, part of the circularity of this.
It is part of the project, and to me, it is the main challenge because aggregates in UHPC are half of the volume of the material, and they need to be of high quality. So it's a big challenge. It is more easy with the fibers. To use fibers from other sources, it's more easy, and we are also open to collaborate with your ideas and your opinions in this field. Thank you.
Perfect. Many thanks.
Interesting.
Sorry, because I don't know if from
don't know
home
yet.
they are listening. So I come here with the microphone. Do you want to?
Yeah.
Okay.
Nadia, you're Nadia, right?
Yeah.
Nadia asked if the beams have 40 meters long. No, we don't know the length of the beams. I'm explaining what's the maximum length that we more or less we can afford in our precast factory. So if we go beyond, we know that we need to produce the element in the port or next to the port, which means a totally different logistic. 40 meters is okay because with two beams you could save 80 meters, which is more or less the design of the first design.
Many thanks, Esteban. Now I give the floor to the Technical University of Darmstadt. Our project partner is Ivan Ukrainsic. I hope that I spell in the right way your name and surname. So he will talk about modeling and testing, and so about durability and maintenance. So Ivan, the stage is yours.
Yeah, thank you. Yeah, I have the task to talk about the modeling and testing. So it's part of the work package 3, predictive modeling tool. And yeah, our group is leading this work package, and it's chaired by Professor Konders. I also got inspired with a very nice video. Thank you for this. So it's yeah, this is our dream. So I also I believe that the UHPC is the right material for this kind of application. I also believe Esteban, given the durability, although of course we need to wait 100 years to be sure, because it's a new material, and to see how it performs in real conditions, only the time can tell us. And this is actually why we need modeling, because durability we can really only to be able to predict in the future, because we cannot wait for 100 years. We really need modeling tools. This is why the work package 3 actually combines work package 2 and 4. You will see later. Yeah, because we need to inputs for the models, and we also need to validate the models. So the harsh environment, what we already heard, yeah, those are the chlorides basically, or there are some other ions inside. And yeah, we already have a long history of durability in concrete. And I personally started even my master thesis already. I'm a chemical engineer, and even during my engineering studies, I worked a lot on durability of concrete, on film studies, because my father was a very respected concrete technologist, and he was doing a lot of this durability field works and designing of concrete. And yeah, we gathered a lot of data. And for that, I did in my master thesis, I used the artificial neural network to analyze all this. So it was the data science behind to analyze all these kind of classifications. And you can see it, yeah, until you really have the problem, basically you don't see you have the problem, because until here we can see the reinforcement still and the concrete cover, but until it's exposed, you don't really see the bar below is corroding. Yeah, here one example that UHPC is already really reality. Maybe a nicer picture from Esteban I would use next time. But here is, yeah, Chinese are also ahead in UHPC in applications. And yeah, we heard that our challenge is actually not only a UHPC, but also to make eco UHPC. Because in concrete, in normal concrete, here you can see the normal concrete, but when you compare it to UHPC, you can see that we don't have the coarse aggregates, and what Esteban just told, that most of the volume, actually here I show it by mass, most of the amount is fine aggregates. So this is why also an idea in the proposal that in the project that we actually replace the aggregates, and so we can use recycled aggregates, fine aggregates, and this is and by also the next step is the cement, to make eco-cement, because yeah, the cement is the highest CO2 production. So really we need to reduce the amount of CO2 footprint from the binder, and this is of course this is done by supplementary cementitious materials. So we will explore different binder supplementary cementitious materials, and yeah, then we have fiber and a lot of superplasticizers to make it flowable. And here you can see, yeah, basically this is really increasing the footprint of the HPC, also the price, the footprint of the CO2, because we have a lot of cement. But as Esteban told you, because we use less concrete, the bars will be thinner. This is one argument that this is still a more sustainable solution, which needs to be checked by LCA, of course. But another argument, even also very important, is that the durability is increased, and if you have less maintenance costs, you don't need to replace covers or make maintenance even in like 15 to 20 years. Like in the picture I showed you from my master thesis, that was like after 15 years, you already can have such a big degradations, and you need to really maintain structures. And if this concrete UHPC is really durable, this is another big argument that will make the LCA really much better, much less CO2. So Esteban talked a little bit about the properties. So he already mentioned that we have the multiple crack behavior. So this is the normal concrete. So already the tensile strength is like can be 2 times more better. And but the main thing is that this area, this is the deflection. So deflection is also almost 10 times higher. Also very nicely you saw it from Esteban's picture, and but because of this multiple crack behavior, also under pre-stressed conditions, so the rebars, we can yeah, this is actually could also be, although Esteban said it, they are closed, but we see it also maybe as a potential durability risk. So we need to address these cracks to predict the durability. And but the diffusivity, which is actually governing how much chlorides diffuse through this concrete cover, because then when they reach the reinforcement steel, then the corrosion starts. So this is the main focus. We focus on the chloride ingress, And I think I will explain it in next slide. But first, of course, there are some drawbacks. And this is the question of sustainability and also the long-term durability. We have to be able to predict it. And especially if we do eco-concrete, because now we are replacing part of the wood cement with, we are also using recycled materials. So how is this affecting the durability? This is everything what has to be considered later in the LCA. And for that, we need to have good predictions for the durability. Another drawback is early age shrinkage and also the cost, which we heard, but of course, if this is adjustable, then the costs are not the problem, should not be a problem. But we also heard from Esteban. So now I will talk about why chlorides, why chloride ingress, because if this is, now this is the cross section and we have a rebar here. So this is the chlorides, they diffuse or ingress. There are more mechanisms involved, and we ask. So this is the concrete cover, which is actually made the main cover that is responsible for the durability that passivates the steel, because concrete is a high pH and this passivates the steel. But when the chlorides reach, so here you can see the chlorides. If you spray it with silver, then you see nicely the penetration depth. And when they reach the steel, then they activate the corrosion. So for this, we have different tests, how to test. This is one, for example, a rapid chloride migration test, or which is accelerated by voltage, or we could use just natural diffusion tests. But when you split, make a cross section, you can see it in the concrete. This student from Eddie in Delft, he did on a normal concrete and slack concrete, and they found that actually, because the binder is much denser, the microstructure of the binder is much denser, so the interfacial transition zones between the aggregates and the paste binder are more porous, and you can see how the path actually follows these interfacial transition zones. But now we don't have the big aggregates, but still we have the transition zones. So this is how it would look for the mortar, but it's not UHPC, it's just normal mortar. And here you can see it for the paste, so just the binder. And actually, it's we can model it by the diffusion model. This is just a simplified way. And but the diffusion coefficient is one of the key performance indicators, because it will show how long the chlorides take to reach the reinforcement steel. And here I wanted just to also mention that there is a Ryland TC meeting on the durability methods of blended cement paste. So it really goes along with this. And we are reviewing there the test methods. And here you can see on this picture, for example, that this is just for the binder with different water cement ratios, which basically means more porous or less porous, that the diffusivity. So here it's called the relative diffusivity. That means how much the diffusion is lower than in the normal solution without pores. And you can see if you lower the water cement ratio, that means that you have the lower porosity. Basically, it goes 100 to 1000. So 2 to 3 orders of magnitudes, it lowers the diffusion process. But for UHPC, we are with very, very low water cement ratios, like 0.2. So this is why it explains that we have almost 2 orders of magnitude lower diffusivity than in normal concrete. That actually directly explains the durability. And but this figure is just for normal Portland cement. So we need more data on blended cements. This is why there is this Ryland technical committee, why we are reviewing what is the effect of supplementary materials, and we are doing that on blended cement paste because it gives much faster way, like faster way than doing measurements on concrete and with including the aggregates. Of course, aggregates are important, but just to classify the materials, which SCMs are good, and see how they have the durability. First step is easier to do it on the paste directly. Here is how the methods looks in TU Darmstadt in our laboratory. So we first drill the cores, and yeah, there is this is called a rapid chloride migration test. So we use the voltage to, it's a standard test, because otherwise for natural diffusion you need to wait for a long time. So that's why we use in the standard, we use voltage to speed up the chlorides, because chlorides are negatively charged, so they are attracted by the anode. And here we have the solution of chlorides on the one side compartment. The chlorides go in. That's why you can see already here the penetration zone, the ingress depth, and on the other side is natrium hydroxide solution just to keep pH. Now, how the work package 3, so the improved predictive computational tools. Of course, we have inputs from the work package 2, which is directly giving us the mix design, curing conditions, bio-based coatings, what type of materials, so all the inputs from the material types and mix designs and characterization of the materials. And but the work package 4 is on testing, so it will also give us inputs, but also gives us how to validate our models. And in our work package for the improved predictive computational tools, we have 5 different levels. Actually, we follow the multi-scale approach. So first we do the binder. That's the microstructure of the matrix, of the binder matrix. We are using thermodynamic modeling to predict the phase assemblage and the hydration, how it develop the pore structure. Then we have the modeling of the surface treatments. Then we have a mesoscale model, what I will show later. So we include explicitly the aggregates in that interfacial transition zone. We also need to have the mechanical model, because the mechanical, then they produce cracks and then directly influence also the durability. And at the end, because these are quite sophisticated, high fidelity scientific tools, but at the end we want the engineering tool, and this will be a probabilistic predictive performance toolkits, which basically will predict the chloride ingress from a probabilistic engineering point of view, but also taking inputs from the previous more advanced tools. Have new materials, we need different inputs for this kind of standard tools. And we also want to include in this predictive tool not only chloride ingress, but also coupling with the mechanical model. But they will be analytical models, so that will be simplified for engineering purposes. So the mesoscale approach, yeah, you can see here again simulation how the chloride is ingressing, and those are the aggregates. Here we have the still bar, and here we have the chloride profile, and there is some certain critical concentration. When this critical concentration is reached at the rebar level, the reinforcement still, then it starts the corrosion. So this is don't want. And basically, if this is reached, then you need to remove the concrete cover and put a new one. But now we have new materials, so we have blended cementitious materials. I'll talk about it later, but first I will talk about the aggregates. So we want to use recycled aggregates, and here this is a natural fine aggregate. Here we can have now also, if you use recycled aggregates, these recycled aggregates also contain a mortar, attached mortar, or attached paste on it. They are not just aggregates because they are already were in the matrix of the paste. So they when you crush them, you also have not the aggregate, but also the mortar or the paste. So we have different types of interfacial zones that will then influence the chloride ingress. And here, yeah, we would like to also then put the coating, and this should be the bio-based coating because yeah, there are many coatings, but for the sustainability point of view, we really need to shift to the bio-based solutions. So this will be also another big challenge. And I did also some work in coatings, but we used styrene, but again latex, which is actually, I would even argue, not so sustainable. But it's actually in the US, they use it as a common solution for roads and bridges. When they have to remove the cover and repair, then they use also certain, they mix it with certain percentage of latex or just spray it. So this is the coating. During my studies, we had actually a home in a garage. We were using this kind of, we were selling, because my father, he was putting this in the engineering practice, but then nobody, we had like a company that were selling this kind of additives for concrete. Yeah, and now the paste, here we have the thermodynamic modeling, so that we can predict how the supplementary cementitious materials, how the eco-cements, what is the best eco-cement solution, because we need a microstructure to replace the cement. We can use this very powerfully with the thermodynamic modeling, because then we can predict the phase assemblage, we know the porosity, we know which kind of phases are forming. And of course, for UHPC, it's all about for the performance, I would say it's all about the packing density. So we need to pack the aggregates and also cement particles and fillers and supplementary cementitious materials. But it's also the chemistry, and this all influences the workability, rheology, so flexibility, strength, and also then durability. Here I found one from the literature, Thomas. This is a high performance concrete, and here we see the chloride ingress for the ultra high performance concrete, and you can see really how much less chlorides are ingressing in ultra high performance concrete. And this is my last slide. I just want to this like my conclusion. For the KPIs, also very important. I summarize this. So we have the inputs for the mix design and curing conditions. This is the modeling part, and here we want to validate parameters in different steps, in different scales. So it's a multi-scale approach, and we validate with measurements and results. And so first, here we do the base, the binder, for the micro level, let's say. And for this, we have two tasks on hydration modeling and coating modeling to see how the coating also interferes with the concrete. And then this is the meso scale. So we need to explicitly model the aggregates ITZs, so the interface of transition zones, how the preferential pathways that the chlorides take. And but here we need for this we need input for the diffusivity of the binder. And here we have the output diffusivity of the mortar, and this should be tested. And that way we can validate and calibrate our models. And then later we can also test it in the real conditions. And for this we will use a probabilistic approach. And with this, at the end, because we will have also parameters uncertainty and the real boundary conditions, then we can the probabilistic approach, we can take into account the uncertainties and predict the durability of the structure. Yeah, thank you very much.
Thanks, Steven. We have a question from online. So just okay.
Sorry, I was trying to see the question. Maybe this one? No? To reduce the risk of corrosion, this was already answered, maybe? Or not? No.
Partly, yes.
We have any requirement on FUT or FUTU tensile strength?
Yeah, sure.
Juan Calama, okay. So the answer is yes.
Yes.
Okay. And this question, to reduce the risk of corrosion of steel fibers and weight thickness of the structure, have you considered using other fibers, for example, carbon, polymer fiber, or using textile reinforced concrete?
Maybe Esteban.
Yes, maybe this is a question for Esteban. Sorry, because of the microphone.
This moment, in my opinion, in terms of performance cost, the most efficient fiber is the steel fiber. Building something precast with textile concrete is complex, at least with our procedures. I think there are few references.
Perfect. Many thanks. Does someone here in the room have any question for Needham? One here.
To introduce myself, my name is Hessel Noni. I'm working for Oxus. I have a question about the testing. Taking into consideration that these structures are floating, part of them is permanently underwater, part of them is kind of tidal zone. My experience in testing always split it up. Way that we use carbonated concrete and uncarbonated concrete. And why I think this is important in this case, because if we shift to less OPC, in mixed design, there will be, or in the mix, in the concrete, there will be less bottom dies available. Ending up with a more permeable structure. To take that in consideration, but also in respect to what I expect, the higher content of the high percentage of reinforcement due to the high strength and the high models. Actually, it's true.
Thanks.
That's a good point. We wish to consider also that. But this is, we also say, I think it's multidisciplinary. Of course, we will focus more on crazy sandwich, what you say. You have different SCMs, so with the thermodynamic modeling, then you have the also the mechanical part is actually done by a different group. In this collaboration, we hope to answer these questions.
Many thanks. We have another question by Janet Sperko. So it is difficult to assure homogeneous properties of recycled aggregates. Is it not a risk to introduce this uncertainty into a relatively new UHPC material? How many experiments are planned? For this question, our coordinator will answer. Many thanks, Juan.
Okay, I think that's a very good question. Well, the approach was following this first, acting on the part that had the largest environmental impact, is the cement. So we will first try to modify the cements using high performance concrete by eco-cements. Then, second step will be working on the fibers. That is the second most important parameter. And the last one will be the aggregate, because also we think that it will be very difficult to work with recycled aggregates of quality, or the quality we need, out of the size we need, because in the high performance concrete, the size of the aggregate is really fine. It's very small. So getting recycled aggregate of quality could be required more CO2 production than using the natural one, I think so. That would be our last choice, I would say.
Thanks, John. And thanks, Niven. Perfect. We keep going on. So we skip the 5 minutes break. I hope everyone is okay about that, but we want to finish on time. So we keep going on with our next presentation that is about social aspects related to this project that are, of course, very important. So many thanks for being here. I introduce you to Neil Dunphy from the University College of Cork in Ireland. So Neil, the stage is yours.
Thank you. Well, probably it's almost sacrilegious to a group like this that's so focused on technology, say that technology is not always the answer. And technology is never the whole answer. It's never the complete picture. So we as a people knew about the power of steam for thousands and thousands of years. But the societal conditions didn't enable us, didn't force us to think about how to make it work for us. It was a toy. So this is ancient Greece. And the simple steam engine you see here was just a novelty because it has slave labor. They didn't need to implement it. So we need to think about, non-technical dimensions of innovations. And very often it's the non-technical barriers to adoption that are the most difficult to overcome. Again, I'm sure that's almost sacrilege, the engineers and scientists among us. So non-technical barriers are significant impediments to renewable energy supply. We've seen that already, and it has really slowed down our transition to a decarbonised future. In addition to the economic considerations, which are obviously top of everyone's mind, and we've seen already how the levelized cost of energy is going to be taken into account in this design factor, there can be regulatory, environmental, and social barriers. And these are often far more difficult to overcome. At least with a scientific problem, and I have a natural science background myself, I am a scientist, but at least with a science problem, you know what the problem is. People are far more complex. It's often far more difficult to even define what the problem is. So within this project, at NaturSea-PV, we're going to look at the 3 aspects of non-technical barriers. We look at planning and regulatory assessment. So we'll continue the spatial requirements of floating PV and ask how this might impact positively or negatively on other sea uses and activities. And very often we overlook this, that there are other people involved in all of this, and simply putting out a big installation in the sea is going to impact on many other uses, some economic, some social, some recreational. So this will help planning and site selection for future floating PV deployment, and hence it's an important input into regional and national maritime spatial planning processes, and this is going to be a key part of this work, looking at the maritime spatial planning processes. So the task is going to come up with a hypothetical spatial area for a commercial scale project. Consider other relevant siting conditions: water depths, distance to shore, access, navigation restrictions, water contact footprint, and overall area of influence. Regulations and standards related to construction, transport, and deployment will also be taken into account. So this work will take part in the second part of the project. So it's after the initial designs come through, and it really is part of the testing, I suppose, or the verification part of it. Second one is environmental considerations, and this will consider environmental impacts through a comprehensive review of literature coupled with expert judgment, assessing, defining, and finding what needs to be taken into account in the future. So the analysis of broader marine law and policy will also be included, and examples of the Marine Strategy Framework Directive covers such things as water quality, introduction of underwater noise is going to be an issue, nature conservation directives to protect certain habitats and species will all be taken into account. And this noise and the impact of deploying structures in the sea and what impact that has on what's known as the noise scape of the marine environment is going to be key to this as well, how that would play into it. And a particular emphasis will also be placed on potential positive aspects of deploying some structures. So very often what we see is when you deploy a structure and see that it acts almost as an area of conservation, and that sea life and be somewhat protective, for example, from fisheries and so forth. And these positive aspects will also be an important consideration in the life cycle assessment. And we've seen earlier that there's some talk about how the trade-offs of the thickness of the concrete versus the carbon and resulting, in fact, an overall improvement of greenhouse gas performance of the material. So an environmental impact assessment of the construction, transport, installation will also be carried out using data gathered in the project. Again, this is going to be later in the project once the initial designs come up. This is just the overall scope of the approach to LCA, and I'm sure that you're all familiar with this. But the key thing here, and the laser was working out with point ahead, is the goal and scope. So how you establish the goal and scope of any life cycle assessment is going to be key to what you actually find out at the end. So work that we have commenced already in this is looking at the social and societal implications. And here we were saying that inclusive engagement is vital in order to better understand the societal context and the possible social implications of applying floating PV. And here I have some nice pictures of random people. But what I try to express here is that, looking at the human dimension is not just talking about people who live in the coast. It's not just talking about those who are directly impacted, but that there's impact right across the life cycle of the product. So in deploying any type of infrastructure, we always look for acceptance. Look for the local communities to accept what's happening there. But this acceptance really often implies a kind of passive acquiescence. We know best. We're going to tell you what we want to do here. This is why you should agree. Now agree. And if you don't agree, then something wrong with you. And it's usually more concerned with advocacy, as I say, rather than the decision-making process. And it's a so-called DAD model. Those of you who are dads in the audience, like this, it's decide, announce, defend. But very often happens, it's actually DADA. Decide, announce, defend, abandon. Because you can't get acceptance, you can't get permits, and there's opposition, and very often this will slow down projects, if not completely cause them to be abandoned. So we tend to talk about social acceptability rather than social acceptance, and we try to build acceptance into the projects themselves, into technical innovations, and this infers a desire to design and implement a project that is more inherently acceptable to the social stakeholders. It suggests, and I would say it requires, a more participatory approach so that you involve people, not necessarily giving them a veto, but that you involve them in the decision-making process and that they're both acknowledged and shown to be real and legitimate stakeholders. So the question then of what's fair, and what's fair to me may not be what's fair to John or to any of you. It's really is all a matter of perception, and I'm sure the dog on the right here is a dog on the left. Your left is seeing things a little bit different than the other dog. And in terms of energy justice, this concept of energy justice, we talk about the three tenets of energy justice. We talk about procedural justice, that things follow the rules, the processes follow the rules, that things are done right in accordance with the regulations and best practice. We talk about recognition justice. This is that people are acknowledged as stakeholders. So very often, when we do this, we might acknowledge one particular group of stakeholders and involve them, but exclude someone else. So it really is about recognition of people's right to be involved in the process And then the third one is distributive justice, that there's an equitable allocation of benefits and ills of a particular project, particular technology. So what we're doing at the moment is we're selecting a number of communities for this engagement. We will be engaging with them quite in that way so that we come to understand their attitudes, their desires, their practices, and how they would impact on the design of the technology. And that's what we hope to contribute to this project. Thank you.
Really interesting presentation. For me, that I'm not a technician, so maybe this is the one of the presentation I understood last. But okay. Someone of you has any question? Here.
Thank you very much. In most cases, when develop this kind of projects, what people are against are very easily voicing themselves. The people that are in favor of, let's say, natural is tend to keep quiet and silent. So how can we inverse that tendency? And how can we make sure that the people that are in favor are actually defending also their opinion the same way that people against are doing?
Thank you for the question.
Very common question I'm asked. And it's a natural way of looking at things. These people are against me, they're loud, these people are at least neutral, maybe for me, they're not speaking up. How can I get these people to be louder? But that's not really the problem. The problem is trying to understand where these people are coming from. Some of their opposition will be legitimate, some will not. That's why we need to engage with these people. These people are already on our side. By them speaking up, they're not going to persuade anyone else. And they're definitely not going to persuade these people. So it's engaging with these people is really the challenge. And this is why, I suppose, before any deployment of any technology or development of technology, that you need to engage with prospective host communities, understand their values, understand what's important to them. And those three elements that I spoke about, the recognition justice, distributive justice, and procedural justice, very often people can't articulate why they're against something. But it may simply be because something like procedural justice, that an information workshop was held 50 kilometers away in the dead of night with no publicity. No, and that type of attitude by people who are deploying technologies can very often be counterproductive. So what we need to say to people is you engage early, you give as much information as you can, you be upfront, and you speak to the things that have been raised. You're not going to convince everyone, but it's far more important to persuade some of these people who are against you rather than get the people over here to speak up more. Because the regulatory authorities are not going to be influenced either way, really. They know what the score is. I hope that answers the question somewhat.
Perfect, many thanks. We have one hand up from home. Janets, please, you can switch on your microphone if you want to ask something.
Yeah, thank you. It's easier like this than writing. Thanks for a nice presentation. Well, my question is actually the story is in Belgium was also they tried to build, let's say, accumulation dam on the North Sea, and then it was the local sailing club that said this will not go through, so they stopped the project. So indeed, the stakeholders can have a big influence, even a veto, right? Of course. So my question is, how will you choose these regions? So obviously somewhere close to the sea. Will this be only in Ireland, or will be this in different places? And well, how you will use the stakeholders that they will participate?
So we will take a very First of all, we take a very inclusive process. And we're currently undergoing a scoping exercise. We're looking at different prospective host areas, host communities. We want to try and select communities that will add diversity to what we're looking at. So in some areas, there may well be sailing clubs. In other areas, there may well be, fish farms or other aspects. We want to try and capture as much diversity of stakeholders as we can. It won't just be in Ireland. We will say, again, we'll aim for diversity of that. Engaging with people then, we will do that through a mixed method approach, starting off with typical surveys, but just to try and get a lay of the land, as we say. In-depth interviews with people, so they will be carried out face-to-face. We'll use process like focus groups, Delphi panels we're often using now to try and capture expert opinions. And when we say experts, in this context, very often people themselves are experts in their own life. They know about their community, they know about their area. So it's not us in this room or the experts, but if we're going into a community, it's perhaps the local mayor or the local head of the Chamber of Commerce or so forth would be the people who will really inform our thinking. And we're still deciding on the communities. We're going to scoping exercise, which will take into account technical requirements for deployment, and then try to get a diversity of locations that will include different countries. So we're aiming for 3 different countries. I hope that answers your question.
Yes, absolutely. Thank you.
Yeah, just to add a little bit to that very nice answer, I just wanted to say that the spirit of this event and this part of the ADN of the project is listening to all those that think that we are doing anything wrong. So it can be either from a technical point of view or from a social point of view or whatever you think. We want to hear you. We will take into account those opinions, and if there is anything we can change within the project and to get in the end better results, but we might be wrong. So if someone tells us early on that it's better if we change slightly our approach or something, it's just perfect. That's what we want. So he or she just has to put in contact with us. We have the LinkedIn channels, the Twitter. We have our emails in the presentation. So just contact us and give us your opinion. That's what we want. Thank you.
Thank you, John. And thanks all for your question and your contributions. So we are going to the last part of our event that is related to the requirements, KPIs, and after this short introduction by Inigo Mendicoa from Tecnalia, we will start with our roundtable where we have invited coordinators and partners from other projects just to show what their technology they are developing and what are the innovations that they propose in the same topic of NaturSea-PV. So I asked to Inigo to come here on the stage. The floor is yours, Inigo. Many thanks.
Thank you, Sarah. So most of the things I will say today has already been said this morning in different sessions, so I will not go through this in more detail. So it will be kind of wrap up of everything as we have explained this morning. Normally, when we start an activity, the first thing we want to do is to define what we want to do, how are we going to do this, so what are the main requirements of the different products of the project we are developing, and what are the main KPIs we will use later on to assess how good or how bad is what we have done. So I just recall what are the main results of this project. We are defining new concept of substructure with the components of this material have been described this morning. We're also defining new materials and coatings. And we're also defining a new set of computational tools to predict the main physical phenomena happening within the material and the coating of solid. We are not only focusing on technical requirements and KPIs, but as already been said, we also need to consider environmental aspects, restrictions, also how does it affect to social and economic activities. So based on all these considerations, we are defining the main requirements and the main parameters to assess our results. So just a quick summary of the main requirements we're considering. First of all, for the structure, the main requirement that it has to survive. It has to survive in different conditions. It's not very clear what are the worst conditions. We have defined here a typical parameters of what is considered extreme environmental conditions. This wind, current, and wave significant height 40 meters is quite hard conditions, especially we're considering these are simultaneously acting, which is quite conservative approach, but can happen. What is not very clear is if this is the worst condition for the platform. As William said this morning, there are shorter wavelengths that could be worse for the platform, could be worse for the components. But anyhow, this is normally the worst condition for sure for the mooring and for the cable. In this project, we are only designing the platform, the components. We are not researching about mooring lines. We are not researching about cable, but for sure we need to consider this. We need a mooring system to the test, to see how the whole thing is performing. We also need to define a cable. We are not researching, but we'll take a commercial cable to see if this is capable to survive to these kind of conditions. The survival of the cable normally sets the maximum offset of the platform, and this means this is a requirement for the mooring design and for the mooring line pretension. So we need to consider the cable, even if we are not designing one, we need to consider this also. This is the strain conditions requirement. Also for the normal conditions, we also need to impose the requirement, try to avoid the immersion of the panels, because this could affect the production of the electricity. This could also compromise the survival of some panels, maybe. So we try to avoid as much as possible the immersion of panels in any condition. Of course, the requirement is the durability. We haven't set a lifetime, maybe 20 years is typical for these kind of installations. And this has to do with the mechanical fatigue of the material, but also the corrosion, and this is a requirement for the coating space. One important thing is we are not researching on PV panels. We are considering traditional commercial PV panels, which normally cannot bend. So if we are designing the beams to be able to bend, we have to make sure that the PV panels are not bending, because they are normally quite rigid. So this is a requirement for the connection between the panels and the beams. And of course, the main requirement always is to reduce the cost, reduce the level cost of electricity. And of course, we also have to consider some environmental requirements. We have defined at least these 3 parameters to reduce the carbon footprint, to reduce the energy consumption, and to increase as much as possible the recyclability. Few examples of the parameters we have set as a requirement. You can see this reference value of Formex, which is a commercial product. We plan to get over 30% of reduction in the carbon footprint with respect to this commercial product, and to increase the recyclable material over 35%. One important question here is the increase of eco properties are compromising the mechanical properties. We don't know this, or we don't know to what extent. So we need to analyze this compromise between how eco can we be without compromising too much the mechanical properties. Not all parameters are quantitative, we also have some qualitative requirements. Most important is that the platform accessibility is important for the maintenance operation. You know how expensive it is to do anything in offshore environment. So we need to do the platform as accessible as possible, and also to do an easy deployment for the installation and for the decommissioning. So we need to do the platform as easy to deploy as possible, because everything is quite expensive there. The modular design, we're focusing on the one lily concept, but maybe we can go to another, joining different lilies. So maybe modular design is important as a requirement. And finally, for the coating, we have set the bio content over 80%. We will see if this 80% is compatible with the properties of the coating. Some KPIs related to the platform. We need to measure how it is behaving. First of all, the kinematics of all the floaters, because it affects to the production of the PV panels. So all this degree of freedoms of every component has to be measured. We also have to measure, of course, the stress and deformation of each component to be below acceptable values. The mooring line forces, we are not researching mooring line, but we have to define a catenary system, so we have to measure the mooring line forces. And of course, the performance of the PV panels, which is the production of our installation. It's important to know that depending on the wave, the sea states, the PV performance can drop. We can drop energy production up to 10%, something like that, depending on the sea state. So we have to be able to quantify the energy production for different sea states. I have said before, the limiting states. I have said that we put example of the extreme conditions, but as I said before, we don't know what are the extreme conditions. So we have to analyze all this for different sea states. As I said before, we have defined some environmental KPIs, carbon footprint, energy consumption, recyclability, and of course, we need KPIs to estimate the costs through the life cycle of the system. So how can we estimate the COE? We can estimate the performance, the energy production, and the cost. And with this, we can estimate the COE, which we want to minimize. Regarding the modeling tool, we have to develop. The main requirement is to be able to predict the durability of the components. And to do so, we need to model the main physical phenomena happening there, the adherence between different monomers of the coating with the concrete, the chloride diffusion, and other phenomena happening there. So what are the main KPIs of these modeling tools is the accuracy on the modeling, the properties of the material. Computation time can be an important KPIs, but normally it's not so critical. The main point is how accurate is when predicting the durability. Finally, as Neil said before, we have not only technical questions, not only technical restrictions, but also some environmental and socio-economic aspects that we need to consider. Normally, environmental restrictions are related to the impact on the ecosystems, to animals, to seabed also, because we are not only in the surface, we are also in the seabed. We are putting anchors, we are putting mooring systems, we have the installation, the decommissioning, so all this can affect the seabed as well. So the point is we need to consider all these aspects, even the influence on current, local current and waves. Normally this is not critical aspect, but has to be considered as well. And the influence on socioeconomic activities. For example, this is incompatible with fishing or incompatible with some sea sport or other activities. As Neil said before, we are not focusing on a real location, but in a generic way, we have to consider this generic restriction from the environmental and socioeconomic aspect. And this is a quick summary of what we are doing in requirements and KPIs. This is an ongoing task. The plan is to have this finished by the end of April. So there should be a public deliverable in May. And we're open to proposals, suggestions, because we have considered some generic aspects. But for sure, there are many others that you can do at people online. Can give us some valuable input, so we will be very happy to hear you.
The questionnaire to contribute.
Many thanks, Inigo. Of course, if you have any question, okay, we have already a question here from one person in presence. If you have any questions online, you can decide if you want to write in the chat or put your hands up and we will give you the floor. I just want to tell you that in the next days, you will receive a questionnaire that is related to the event, of course, but mainly to KPIs and all the activities we have just explained you related to the project, because as the project coordinator said before, we need your feedbacks to improve and to understand if the way we are, the path we are underlying is correct, or if we have to consider other indication, other suggestion from you. So you will receive it in the next days. I kindly ask you to fill in it. It will not give you so much effort, so please, it is very important for us. So we have a question here for you, Inigo.
Hello. Thank you for the presentation. I'm Naman. I'm also from the Marine. I have one question and suggestion. Do we take into account of the maintenance walkways for the on the surface of the lily to reach to each panels to do the maintenance? Because that will take a lot of space on the platform and will reduce the power production.
Thank you.
Yeah, thank you. Yes, thank you for one of the main requirements somewhere here is this qualitative requirement. One is to make the platform as accessible as possible for the maintenance. And of course, we have to quantify this. And also we have included in the economic parameters somewhere here. Parameters like this, mean time between failures, these kind of things, to estimate also the cost of the operations. So the maintenance is one of, we are estimating the cost of the full life cycle. So part of it is the maintenance. So we will have to define here more specific parameters to quantify the cost of these operations. You know, in offshore environment, everything is expensive. So we need to reduce the number of operations. And for each operation, we have to reduce the cost of the accessibility. So yes, for sure, we have to consider the operational maintenance here as well. I think how can we quantify this? Not always easy. Thank you.
So we will proceed with the roundtable.
Yeah, we need a few minutes to prepare this.
Okay. Can we start?
Yep. And now if there is online.
Is there a question? Okay, sorry. Balaram is asking, do you have tentative estimate of LCOE of your concept?
No, as far as you know, we don't have a figure on this.
Not yet.
What we know is we want to reduce this, that's for sure, the typical reference value. But I can give you now a specific thing.
Okay, another question from John. Will the LCOE KPIs targets in this project be based on the LCOE of existing offshore renewable power systems, for example, the LCOE of offshore wind?
I think the reference for us is an existing floating PV infrastructure. Of course, we have to be competitive also with offshore wind and other energy sources. But in principle, we'll take some reference the eco-cementitious of existing floating PV. They are not in OpenSea, so it's not fully comparable. But our reference for us is this: so try to reduce the eco-cementitious with respect to comparable infrastructure, which is not offshore wind for sure, but other floating PV infrastructure, even if it is in sea or lakes, I say it's not completely comparable. We know there are additional costs in OpenSea, so for sure we cannot reduce the cost of these installations in a lake. But as a reference, try to get as much as possible competitive. Thank you.
So now I ask to Ana Brito.
One comment, we have two presentations now of other projects that were competing in the same call with NaturSea. One is about the floating PV also using concrete with the Surway project. Another one is that Anna will present to us today, which is not about floating PV, is OTEC, which is thermal gradient energy source, which is another different marine renewable energy. So it's not the same topic, but for sure we have something interesting to learn from it. So,
So my name is Ana Brito Melo and I work at WAVEC. WAVEC is a non-profit organization
that devoted to marine renewable energy, so wave, tidal, floating solar, so technologies related with the energy in the ocean. So this project was in the St. Paul, but it's not floating solar, but also uses solar in some way. Ocean thermal energy conversion is a process to produce energy from temperature differences in the ocean. So in the deep ocean, we usually have 4 degrees, and at the surface, we have different temperatures. So it uses the temperature difference between warmer surface water and cooler water at the seabed level, and it requires a temperature difference between around 20 degrees. So this is especially suitable for remote islands in tropical seas. It is in the tropical areas where we have this difference of 20 degrees. How it works. I think this drawing shows how, or it's good to understand how this works. Okay. So the energy from the sun hits the surface water of the ocean. So it's here where we have the solar energy, and OTEC systems uses this temperature difference to power a turbine to produce electricity. So the warm surface water is pumped to an evaporator containing a working fluid, which can be ammonia, for instance. And this vaporized fluid drives a turbine and coupled with a generator. Then the vaporized fluid is turned back to a liquid in a condenser cooled with cold ocean water pumped from the deep ocean. So it's for this process that we have to go for deep waters to have the cooled water. If we use seawater as the working fluid, we can use the condensed water to produce desalinated water. So this is also a product, the additional product that we can have from OTEC system, also desalinated water.
Sorry, Anna, because from home they told me that they cannot see the presentation. Okay. So everything was okay since now, and I know that something happens. Should be wrong, so sorry for that. Okay. Now I think you can see it. Please confirm it.
Yes, we see it now. Thank you.
Perfect. Many thanks.
So here I'm showing the design that is planned for this OTEC. So I just go to the previous slide to show that this evaporated condenser, these are standard equipments. It's not the key point of our project. Our project will focus on the design of the structure where these equipments will be placed, because what we have so far, it's OTEC plants in the shoreline, and OTEC plants in the offshore, where it's more easy to have a deep pipe to collect the cold water. This is the key challenge of our project, is to go to the offshore. And to go to the offshore, this is the design that is being planned by the developer, which is a UK company called Global OTEC. So the objective of OTEC is to design, to model, and to install this successful demonstration of a novel cylindrical OTEC platform that can withstand the extreme weather effects of tropical oceans and be economically viable. It's not seen here, but below this cylindrical platform is where we have the long pipe to deep water. This plant will be demonstrated at flow contest facility offshore Gran Canaria, And these are the key developments. So it's to build and to test a cylindrical floating structure. This is the innovative component. Also to have a cold water pipe to transport the deep sea water from 600 to 1,000 meters depth to a large diameter pipe. Then the gimbal connection. And this gimbal connection is to connect the long pipe to the floating structure. It's also an innovative mechanical joint because it has to be sealed. It has to prevent that in the joint between the long pipe fixed to the floating structure, there is no entry of warm water at the surface. So it's a very innovative component. And also the old computational model development. So to model the dynamics movement of the floating OTEC and the interaction with this pipe, and also the additional effects of the water movement inside the pipe. So the cylindrical platform, Global OTEC believes that this novel design could prevent the need for more expensive and conventional mooring systems in the harsh environments. It's what we aim to demonstrate in this project, and also the material that will be used to fabricate the cold water pipe, which is a high-density polyethylene material. And this material may be the favorite material due to its low cost, installability, and robustness. But we will compare in this project other materials like concrete, steel, carbon fiber, and fiberglass, and also the material that we showed this morning that you are using in your project. So this is also part of the research of the project. So the challenge here is to design the OTEC systems and materials to survive the extreme environmental conditions, corrosion, how to prevent corrosion, the long pipe to sea depths, how to fabricate this component and to be sure that it is more economic than other materials, and to do the modeling of the high tension forces that the riser pipe and joints must support. And this, in particular, this material, the high-density polyethylene alternative solution that will be used in this project. We will also look to the social technological perspective, as we heard in the presentation from UCC. This is also a very relevant issue in this project because OTEC is not very known. When we talk about floating solar, everybody understands what is it because they know the panel solar is in land, so it's transporting to the ocean in a floating structure. It's easy to explain. When you go for OTEC, you always need a drawing and you need some vocabularies that is not common to citizens in general. So it's difficult to understand how much work has already been done on OTEC in the past and the full potential of this technology. And so we need to advance the societal readiness in this project and to balance this with the OTEC technology development. There is also a need competition of the marine space. We know it's growing, so we need to do research on how to co-locate these structures with other renewables. For instance, installing solar panels on the top of this plant could be maybe a solution. Environmental impacts in general, there are some questions that are open questions because there is no much plants of this type, so there is research that has to be done to understand what could be the negative impacts and what are also the positive impacts. And multi-use of OTEC, I already mentioned it, and how this is connected to LCOE cost models. I think that's it. Yes, and these are the partners of the project, which is led by PLOCAN, the Plataforma Oceânica de Canárias. Okay. And hope if you have some questions. Here.
Well, I have a question. It's a little bit related to the pumping. First, how the pumping is initiated? It should be some extra source of energy. And second is like from the energy that you produce, how much of this energy will go to the pumping?
Good questions. I'm not. I have to say I'm not an expert on OTEC. This is the first project in which WAVEC is involved. I think the project will. There is much scope for learning about this, but it's technical details that I'm not able to respond. How to initiate the process? That's a good question. I will keep this in mind too. Yes.
Thanks. We have another question here.
Yes. Hello. Thank you very much for the presentation. I wanted to ask if there are already commercial solutions that are being exploited with this OTEC system, and what is the experience of their durability, how they last?
There are already, I'm not sure if we can say that they are commercial, but there are plants that there is one in Japan, in Okinawa, and there's one in Hawaii, in Nella Laboratory. So they are onshore plants, and working for many years. Built in the one in Hawaii, if I'm not wrong, it was built in the 90s, and Okinawa was built in 2005, I think. So they are working continuously. There's not much information on maintainability, I have to say. There's no public data, and no much published research on these topics. So I cannot say much about these issues on OTEC, but there is a long. I mean, the projects are operational, not in a commercial basis, because I think they are still in the research level. Yes, all these issues are being investigated: maintainability, replacement of equipment, and changing even standard equipment, refrigerators and condensers. Maybe they have to be changed to improve the performance of the plant itself. But not sure about the maintainability, because there is lack of information on this.
Okay, thanks, Anna. We have a question from online also. Sorry, William. I read the question and then I give you the microphone. So, what is the efficiency of the OTEC system? There is a relatively small temperature difference and transport of cold water from high depths. How does it compare to the PV efficiency?
The capacity factor from this plant, the experts on OTEC claim to be 90%, because the temperature, the difference on temperature exists all over the year. The efficiency, I'm not sure how to compare with the PV, with the solar PV. That's a good question, but I'm not. I cannot answer this.
Maybe you will be able to answer after on during the project.
I hope so. Yes, I think this project will be to learn more on.
How many years does the project will last? When it will end?
So it started like you in November.
Okay.
So we are just in part of the project. WAVEC contribution will be on the social, environmental, and economic aspects of this project. So with no much expertise, we don't have much expertise on the OTEC technology. And I think this is a 3 years project.
Okay, so maybe we will update again on the project in the last steps. If you will organize something, a workshop or an event, we will see how the technology will develop.
Sharing information on the materials and also on the component of the social interaction and explaining to communities the benefits of this technology. So I think there is much opportunity for collaboration between our projects.
Many thanks. So another question.
Could you give an example of what a positive impact on the environment would be? Like you mentioned that OTEC can have a positive local impact. So,
I think this area where the platform will be installed will be an area that is restricted for fisheries. So in a way, this will increase the biodiversity in this area. I think this could be one positive aspect. In terms of the environmental, on the other way, we don't see. But it's research that we have to do. We don't see that there is a negative impact of installing this device and collecting the water from deep sea and the warm water from the surface. And then the discharge of the water could have some impact, but it will depend on the depth of the pipe. For the discharge of water, for not changing the temperature at the surface. This is an aspect that we will investigate, and it's usually mentioned in connection to OTEC that could have a negative impact. The opposite, positive impacts, I see more from the side of having a restricted area where you can have more biodiversity. The other on the social side, there is the opportunities. This technology is a big platform, so it's a big investment. It requires a lot of work related with the construction, the installation. And from the social side, this will bring benefits to the community, and as we heard, not only with coastal communities, but those involved in the supply chain. Okay, that's what I can tell you.
Hey, thanks. Thanks, Lena. Igor will present our next speaker.
Okay, so before we have 2 projects competing in the same call, all of them successfully, and we see. And the last speaker today is Joe van der Sanden from Marin. He is not project coordinator, he is background somewhere online. And he will speak about this project, which is also related to floating PV and also working with concrete. So hopefully we'll have some synergies between both projects. Thank you.
Yeah, thanks for the introduction, and thanks in general for having me here and giving me the opportunity to present also our project plan. So far, it's been really interesting to see your plans, and I definitely see some connections between the 2 projects, but also some main differences. So I say I'm not a concrete guy. I'm like William and Laman from the hydrodynamic perspective, working at Marin. Our project coordinator, Balram, he could not attend in person, so that's why I was asked to give this presentation. So our consortium is a bit smaller than yours, I think. So we are with 7 partners distributed over Norway, Germany, Spain, and Netherlands. We are with 4 companies and 3 research institutes, and the project lead is by Sintef Technologies in Norway. And I think a bit different from your project is that we rely a bit more on existing technologies, and we try to see how we can combine different types of existing technology in order to upscale floating PV to offshore conditions. So this is the general design that we have in mind. So the black square that you see is a field of floating PV modules. These are very lightweight structures, as you see in the top left. So aluminum plates floating on the water surface. And we know that these are quite fragile and very light. So they will be challenging for those modules to withstand the harsh conditions that we are facing offshore. So our coping mechanism is to develop a ring of pontoons, concrete pontoons, so-called floating breakwaters. And the objective of these breakwaters, the idea is to attenuate the wave energy and to create a shelter for the floating PV field. So the objective, this summarizes the objective. We want to develop this floating PV field consisting of the PV modules itself, but also this concrete breakwater ring, and also to develop the mooring and all the connections to make it feasible. And yeah, same to you. This below summarizes the objective, the environmental condition laid out in the EU call. In our project, we have defined now 3 field sites in the Baltic Sea, the Mediterranean Sea, and the North Sea. And we try to develop the structure, the concept for these 3 field sites. We have defined 7 specific technical objectives in the proposal, and yeah, we'll just go through them one by one. It's really just a global idea of what we are doing. The first technical objective is on the concept itself, so the PV in combination with the breakwaters. Here at the right, you see again this PV panel. So this is an aluminum plate with very low draft, so it's really floating directly on the water surface. Critical topics in this work package, this objective will be to develop the coupling between the floating modules, like the hinges between the modules themselves, and also mooring connections, to really keep everything, the combined system in place. The PV modules, they are being developed by our partner NaturSea. So this is a small company in Trondheim, Norway. Their design is being tested at the moment for inland conditions. So through this project, they want to scale up to offshore environments. And they've already done some tests in Norway last year. So those are also data that we will use in our project. The second objective is on the integration of circular concrete materials. This is led by partners in Spain, so Acciona and Said. And yeah, their objective is to see how we can make these floating breakwaters, which is a proven technology, make them more sustainable by using new concrete solutions. Specifically also looking at the durability of the concrete. So I think this is very similar to what you are doing in your project. One of the things that we will do in this project is to also look at corrosion and biofouling in seas. So there's a test site in Spain where we can deploy chunks of concrete, expose them for long durations, so let's say for 12 months, and then see what happens in terms of degrading and biofouling. This is the package that back and more comes in. So this is can tell a bit more about this, but I won't, maybe during the coffee break or lunch break. So this package is on computational modeling and simulations. So we want to use a combination of lower and higher fidelity numerical tools to support the design and to assess the feasibility of the design. So the right-hand figure shows the hydrodynamic loads by waves acting on two floating PV modules. So these are some preliminary results that we just obtained. So using these types of calculations, but also aerodynamic calculations to assess wind loads and also current loads on the elements, we want to improve the design. Other types of computational modeling will be structural models, so finite element techniques, for instance. We'll also use artificial neural network techniques for the concrete. I don't know anything about this, but I think it was similar to what TU Darmstadt was having in mind, or at least the term was dropped. And one thing that we will develop is a structural health management system. So this will be like an application on a smartphone that can be used for maintenance. So you would go into the field and then use your application to identify cracks in the concrete. We will also then proceed with testing and validation. So firstly, we will look at ultimate strength tests of the critical elements in the system. So specifically, those will be the joints and the interconnectors between the floating PV modules. Similar to your project, we will also perform wave basin tests at Marin to see the motions in waves and to obtain data for numerical model validation and tuning. And like I mentioned, we will perform these tests in Spain to evaluate the biofouling and corrosion of the concrete. So this together summarizes the engineering scope. And with that, we proceed with also looking into other aspects, also quite similar to what you are doing in your project. We will look at LCAs, not only a regular LCA, but also a social sustainability assessment, which I think, as I understood it, means also looking into the stakes of different stakeholders and see how you can involve local companies in your supply chain. And our plan is to build a stakeholder board with different representatives from different fields and gather their input on their design and see how we can use their input to improve it. And then finally, but least but not last is the economic impact. So the ambition is that we will we strive for a levelized cost of energy of around 54 euros a megawatt hour. So this was the text that was in the project plan. And with that, we hope to be competitive with other sources of offshore renewable energy. Also, with the smartphone app, for instance, we anticipate that also the investment risk will be reduced and maintenance will be cheaper in the end. So this very globally is our project. And just summarizing, so in the end, it will lead to this this design with this floating PV field and the breakwaters using different. The innovation mostly is in the breakwater concept, the use of new sustainable concrete, and development of new computational modeling tools. If you have any questions, yeah, please feel free to ask now, or you can always also approach our project coordinator or our press and marketing officer from NaturSea. So thanks.
We have a question.
Hello, thank you for the introduction, for the presentation. If I understood good, your panels float themselves.
Mm-hmm.
I mean, you have a grid of panels which sustain their own weight.
Yeah, that's correct. Yeah.
One of the main problems of the 2 or 3 offshore tests that have been done with floating solar is the algae and all the biofouling that appears in the surface of the panels because they are very close to the water. So how are you planning to avoid this?
Yeah, thanks. That's an excellent question. We are well aware of that. The biofouling will be very important to take into consideration. We've actually seen that according to the DNV guidelines that have been very recently launched for floating PV, we have to take into account 6 centimeters of biofouling. For these modules, it will mean that the weight increases by a factor of 5. So it's really something that should be considered. In fact, we think that the situation without biofouling is, in our case, not relevant. We have to assume the governing case will be with 6 centimeters biofouling. So that's what we will assume. But we will rely mostly on what's known in literature and being presented by the guidelines. It's not a topic that we will investigate ourselves in the project.
Thanks.
Hi, thank you. Question on the breakwater. What is the wave conditions you assume you're gonna need? What kind of reduction do you think you're gonna need for the panels? And how does it affect the dimensions of the breakwater? I can imagine that at some point they need to get quite large depending on the location and the condition.
Thanks. Also, excellent question. So what's actually interesting about these floating PV units is that they move more in short waves. So the very long waves, like swell, the PV will simply be lifted, go up and down, and the loads on the connectors will be quite low. So it's really also what William was a bit saying in his first presentation is really the steep waves that are governing for the and that's actually why we think that this would work with the floating breakwater, because the breakwater will be especially effective in the short wave regime. So we hope that we can reduce the wave steepness by this breakwater. And then we have to see from calculations how much attenuation we need by the breakwater, and this will set the dimensions. Yeah.
I think that maybe there's another question here. Okay.
Thanks, Jack. One question from my side. Do you foresee any kind of synergy after you know what is NaturSea about? Can you imagine some synergy between 2 projects? Maybe we can sell your coatings or something.
Yeah, so I guess the first synergy is that I'm here, no, I agree. It would be really nice if we can set up some synergy. I think especially on the concrete, but also on hydrodynamic aspects. There are these are real topics that I see clear overlap. Perhaps also on the life cycle assessments. The life cycle assessments, by the way, will be done by Heidelberg IFEU Institute. And yeah, I think so far within our project we've been quite transparent, and we're happy to share lessons learned, and it would be really good to stay in touch throughout.
Thanks. We see just a minute if someone from home has any questions. Or also someone wants to say something. Here you can see, hi, good morning, Balaram. He's the project coordinator.
Hello.
Oh.
Hello, good morning.
Good
I
to
couldn't
see
attend.
you.
Yeah, good to see you all. So when you say the synergy, I think so already we see that marine is a one common partner between these 2 projects. And we see there's a lot of work we are doing on concrete side and also modeling. So we see how we can collaborate with you on how we can create synergy. So it looks there's a lot of complementary work we can do it here.
Many thanks.
Yeah. And thanks, Joy, for presenting a nice Shoreway project. So thanks a lot.
Many thanks. I'm sure there will be other occasion to collaborating with you and also with the other project that Anna showed us before. So if there are no other questions or inputs from your side, I think that since we are a little bit in delay, sorry for that, we can I can say goodbye and I have to say thank you very much for being with us today online in presence. It was a pleasure seeing that so many people decided to join us. I remind you that we will send you a questionnaire with some inputs we want to ask you to improve the NaturSea-PV technology. So this is all from our side. Many thanks again, and I hope we can keep in touch and see you all in person in another event. Goodbye.